And welcome back to another video, 981 time-based key value store. So we want to design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve it at a certain timestamp. So we have to implement this timemap class where timemap initializes the object of the data structure, set stores the key with the value at the given timestamp, and get returns a value such that set was called previously with timestamp previous being less than or equal to the timestamp. If there's multiple values like that, then you can return the value associated with the largest timestamp. And if there's no values, you want to return nothing. Let's actually go ahead and copy this and paste it in here just to have a good idea of what to do when we implement this method. So we'll go this and this. We'll go here. Okay. So, okay. Timestamp previous less than or equal to the timestamp. If there's multiple such values, returns the values such that associated with the largest timestamp previously. And then if there's no values, it returns. Okay. So we'll just keep these in mind. So let's actually put this on its own line. Okay. So we'll keep these three criteria in mind as we're thinking of how to go about the solution for this one. Okay. So as our input, we're given timemap, okay? And okay, and we're given a series of commands. So we have set, get, set, get. We're also given another array over here where you have foo, bar 1, foo 1, etc. As our output, we want to return null, null, bar, null, bar 2. And the explanation for this is when we call the time map string, what we want to do is create a new time map. Then we want to set foo. Okay, we want to store the key foo and value bar. Okay, so let's visualize this with a hash map, maybe. Okay, so we want to store the key foo, right? And then we want a value bar along with a timestamp 1. So maybe what we could do for the structure for this is have foo as the key, and then for the value of the key value pair, we could do foo. We could have like a tuple or something where you have the value bar along with the timestamp of what it is. So we have 1, and we could surround this in an array, which we can call later on. Okay, so next step, we go over here, we take a look, and we have to return bar. So we need to figure out, so this is what the hash map looks like that we have so far. For this one, we want to get what the bar is over here. So we want this to return bar and have that set as part of the output over there. And for this one, like for example, we have like null. Because you're setting something, you don't have actually any return value. You're only going to want to return a value when you get something. So keep that in mind. We'll return bar, and we're checking to see basically the foo key at timestamp 1. We know that's bar, so we're going to have to return that as the value. For the next one over here, we have foo and we have 3, and we want to return bar since there is no 3 value. So this goes to what this is saying over here. Yeah, so if there's no values, it returns an empty string. Okay, that makes sense. And okay, and here we go. So return a value that the set was called previously, where timestamp previous is less than or equal to the timestamp. So if you're given a timestamp of 3 in this case, we're going to look for values of the timestamp previous which are less than or equal to 3. And in this situation, 1 is less than or equal to 3, so we're going to want to return that as the final value. There's no value corresponding to timestamp 3 or timestamp 2. The only value is at 1. Okay, that makes sense. Same thing for this one. We have timestamp set. We set foo bar 4. So we're going to store the key foo. So inside the key foo, and you want the value bar2, and you want to have that set with the timestamp 4. So if we go ahead and try to get foo at the key 4 at this point, we'll get bar2. Same thing with getting it at the 5th timestamp, because the next closest to the 5th is 4. So we're going to have to return bar2 as our final result. So, okay, this makes sense. Okay, like I was saying before, one way we could do this is by having this hash map over here, and then we can pretty much create an instance. So an instance like this for every single key and value pair that we get for it. So we're given the key, we're given the value, we're given the timestamp. We can check to see whether or not the key already exists, and if it does, we'll append the value and the timestamp onto that key like this, and then we'll go ahead and just basically use that for our get method over here. So yeah, implementing the initialization method will be relatively easy to do as well. All we'll have to do is have a hash map for it. So that should be good, and setting should be relatively straightforward as well. The interesting about it, thing that we have to think about here is the get method, because for the get method over here, we could, the simplest solution would just be to, like, let's say like we're given like a certain value over here. So timestamp.get foo at 3, right? So you want to get foo at 3. What we could do is we could check to see over here at foo, we check to see what value it is, right? Well, like we check to see like what value the foo key is at. It's this array over here. And then from here, what we could do is iterate through every single element in the array and search for the correct timestamp or the closest equivalent to it, where it's less than the value that we're looking for. This is an O of n solution, where n is the amount of elements in each key. So one way that we can make this faster would be by utilizing a binary search. And the reason why I'm saying that is because these are timestamps, and as we append it to the array over here, we know for sure that it's going to be sorted. And we know it's going to be sorted because, let's say, like, because as you set like elements at different timestamps, you know for sure, here, this is the constraint. All the timestamp of set are strictly increasing. And by knowing that, we know for sure that we can use binary search to effectively like have the amount of elements we search through each time, which will create an O of log n time complexity. So I'll go ahead and implement this to kind of give you guys a better visualization of what's going on. So first things first, we want to create or like initialize the hash map in which we're going to be storing the values in. So we'll do like let's say self.store, and we'll just have an empty hash map like this. In the set method, what we're going to want to do is we're going to want to check to see if the key is in the store already, right? Well, if it's not in the store, then what we want to do is we want to initialize it. So we want to do the store key, and we want to have that equal to the basically the value, an array with the value and the timestamp over here. Next thing that we're going to want to do is, if the key already exists inside the store hash map, what we can do is we can do store key basically dot append. Let's go else we want to append the store key, basically the new value and the new timestamp over here. So this is relatively straightforward, I think. Just initializing the array over here as part of as the value of the store hash map. Oh, sorry, just one more thing. We need to reference it as self because it's an object within the class. Yeah, looks good. And then otherwise, we're effectively just basically appending it to the already existing array. So yeah, okay. So now for the actual get method itself, go ahead and keep in mind, okay, so we'll go ahead and think about this just a little bit. Okay, first things first, what we need to do is we need to check to see whether or not the value, we need to grab all this array from the hash map. So we want to do, let's say like values is equal to the key, right? Store self.store key. And we basically want to store that. And then what we want to return as our final result is basically like the value, like the value, right? And we're gonna like be searching through it. Let's see, if there's no values, you want to return basically just an empty string. So we need to keep that in mind as we're doing it. So we can do we can have like another value or another variable res, which is equal to basically this initially, and then we can return that at the very end. Return res over here. Now, the next thing that we have to do once we have these two is to effectively or like perform the binary search, right? Binary search. And we're going to do the binary search. We have 1, 4 here. We're going to do a binary search checking to see what the timestamp, like what the timestamps are over here in order to figure out basically like whether or not the value exists at the timestamp that we're looking for. And we're going to grab the basically the previous, well, like if that value doesn't exist inside the hash map, what it should be doing is returning that like any element which fulfills the criteria of it of the timestamp being less than the one that we're looking for. So we'll keep that in mind. Basically we'll start doing the binary search. So we have left and the right, and we want to equal that to 0 and the length of the values -1. While left is less than or equal to right, we're going to want to find the mid, which is just L left plus right divided by 2, right? And then with the middle, what we're going to want to do is check to see whether or not that current middle value is equal to the timestamp. So we'll go ahead and do if the self.store, right? Self.store's value, or actually let's if values at the given middle, right? At the given so we have this value array over here. If we want to figure out what index it's at, we're gonna grab the middle one. Well, we're gonna grab middle one for the middle one at the first one, right? So we want to check to see what the middle value is for the timestamps over here, right? So we want to see if values at the middle, right? At a certain index of the middle at this timestamp is less than or equal to the timestamp. What we're going to want to do is basically set the result to equal the values at the at the middle, right? At the middle, at the 0th index, which is like bar and bar 2. So we'll have that set over here. And then otherwise we want to be moving the pointers basically, and moving the pointers left pointer to the right or the right pointer to the left, depending on what we've already searched. So yeah, like for example, if this happens, if the middle of the one is less than or equal to the timestamp, right? So for, let's say we have the, let's say we have the, like these values over here. We want to check to see, we want to search if the timestamp is less than or equal to that one, that means the left, like the remaining amount of elements that we have to search have to be within the right side of the array, right? So at that point, we'll do L equals M plus 1, so we can basically get rid of what we have to, like we don't have to search the left side of the array anymore. Now for this one, we have to do the same thing, R equals M minus 1. We can get rid of the other part of the array and only search the left side. And at the very end, what we can do is then return the final result over here. So I'll go ahead and just go through this one more time. So we're initializing a hash map over here, and we eventually want the data structure to look like this. the next thing we're doing is when we call the set method over here, we're given the key, the value, and the timestamp. And since we want it to look like this, we have the key set over here if it doesn't exist, and we set the value to equal the value and the timestamp, right? Or actually, let's change these to this format so it'll be easier. Because if we had it with the parentheses instead of a square bracket, we'd have to use dot first and dot second keywords instead of like being able to reference it like this. So I think it actually might be simpler to do that instead. Right, okay. So we initialize the elements, or like the key and the value if it doesn't exist already, in self.store, and then otherwise we go ahead and append to self.store the value and the timestamp. Now the get method, what this does is you set the result initially to an empty string, and then you get the values from the key, right? So self.store key. We do a binary search after that, right? And then we check to see for the timestamps, right? For the middle timestamp value, you want to see if it's less than or equal to the timestamp value. And if it is, you want to replace that as the final result amount. Now, because you're looking for if like the current value isn't equal to the timestamp, and it like basically is like that, then like that means like let's say like the value doesn't exist, right? We're gonna set the value to equal the next closest one, because since we know that the order is strictly increasing, we know that the result will constantly keep updating as you iterate through using the binary search, eventually to the point where you'll get the largest value over here. And then this is basically like cutting the amount of elements you have to search in half by moving the left pointer that you're looking for to the right and the right pointer that you're looking for to the left. And at the very end, you'll be able to return the final result. Okay, so if we go ahead and run this now. Okay, we're accepted. Let's go ahead and submit. Okay. Key error B in line 25. We have the values, and we have self.store key. Oh, right, okay. We have to check there can be an edge case that exists if we take a look. Sorry. Yeah, okay. So there can be an edge case that exists where the values might not even like exist within the hash map. So at that point, we can do self.store.get, the get keyword, and look for the key. And if that doesn't exist, we want to just return an empty array at the very end, where basically both pointers are equal to the same. This will be redundant, and you'll just return the result as an empty string. So if we go ahead and run that again. Okay, there we go. Okay, thanks for watching.